It's my pleasure to introduce Dr. Val Klump. He's the Dean and Professor of the School of Freshwater Sciences at UW-Milwaukee. That school is the nation's only graduate school dedicated solely to the study of fresh water. He has his PhD in Marine Sciences from the University of North Carolina, Chapel Hill, and his Juris Doctor from Georgetown Law Center, and his BS in Zoology. That was my worst class in college. From Duke University. His research focuses on how nutrients and carbon are cycled in lakes. This work has taken him from the deepest soundings of Lake Superior in Michigan aboard a research submersible to Lake Baikal in Siberia. So with that, Dr. Klump.
Right. Thank you. Thanks, Greg. And thank you for inviting me here today. You know, I have a great kinship to this area. I've spent most of my professional career actually working on Green Bay, and I also own a small woodland here in Egg Harbor Township, just a few miles away. So it's been this is a terrific. So I really appreciate the invitation this morning. I'm going to talk a little bit about Green Bay. I could talk a lot about Green Bay, but I'll try not to go too far into that. And then I want to talk a little bit about the Great Lakes. Joel did a very good job of sort of setting things up. Of course, you probably know this, 20% of the world's surface freshwater right here in the Great Lakes. Without question, the largest, most valuable freshwater resource on the planet. Looks great from outer space, but at night, you can see us. So this is and you can see, and the thing of it is, people have an impact on the system. And as a result of that, the lakes are subject to a whole variety of stresses. University of Michigan and others did a study where they did a mapping exercise where they looked at 34 different stresses across the Great Lakes, and they sort of overlaid that. And this is that stress map where areas of red are higher stress. So you can see nearshore areas, Green Bay, and downstream in the Great Lakes have higher areas of stress. If you turn back the clock, many of you in this room probably remember the Cuyahoga River in Cleveland caught on fire. Now, it wasn't the only time that river caught on fire. It wasn't the only river that caught on fire. But it was, at the time, Lake Erie was declared dead, and this particular photograph made the cover of Time magazine, and it is one of the things that was credited with the passage of the Clean Water Act in 1972. As a result of that, we made a monumental effort. We spent tens of billions of dollars to clean up municipal point source discharges. That was the focus of the Clean Water Act. And by the mid-1980s, we had reached the target load for Lake Erie, and water quality dramatically improved in Lake Erie to what I call was what I know as the Seuss effect. If you're familiar, I'm sure you know the book, The Lorax, which has a line in it talking about fish that walk on their fins and get woefully weary in search of some water that isn't so schmeary. I hear things are just as bad up in Lake Erie. Well, at the time, Lake Erie had dramatically improved, and the people in Ohio and around Lake Erie Basin complained to Dr. Seuss. They wrote him a letter and said, hey, Lake Erie isn't so schmeary anymore. And so if you go into the library and pick out a copy of the Lorax, you will not see this line anymore. But on the other hand, things have changed. And this is a satellite image of the western basin of Lake Erie taken a little over a year and a half ago, September. And this is, as Joel mentioned, an algal bloom. Now, anytime you can see an algal bloom from outer space, you probably have a problem. And we definitely have a problem in Lake Erie. Here's another aerial photograph. These are massive algal blooms. Unlike anything we've seen, even prior to the Clean Water Act, that little dot right there is a 1,000-footer. So that's the largest laker that runs, in the Great Lakes, to give you an idea of the scale of this bloom. Joel also mentioned that in 2014, the thing about these cyanobacteria, they're called, produce an algal toxin, which is one of the most toxic neurotoxins known. It's a liver toxin, actually. Exceeded the World Health Organization limit in the Toledo water intake supply to 500,000 people. You can't drink it, don't give it to your pets, don't wash your hands, you can't boil it. Hospitals had to find something else to sterilize instruments in. The zoo had to get an alternative supply of water. And it was seriously a Cuyahoga moment. And we have not solved this problem by any stretch of the imagination. Joel also mentioned one of the sort of impacts of that is when this algae dies and sinks to the bottom, it consumes oxygen. And there are dead zones in central basin of Lake Erie. Here in Green Bay, I'll mention that in a minute. There are some 500 of these around the world. It's a very common problem. The Gulf of Mexico, you've probably heard about the huge dead zone in the Gulf of Mexico. Dan Egan, who is your luncheon speaker, by the way, and that will be, don't miss that because that'll be excellent, did a series of articles in 2014. Actually, Dan was in the Toledo area like 2 days before they shut down the water intake, actually covering this story. I said, Dan, what did you do while you were there? Wasn't his fault. But in any case, and it mentioned the problems we're having here in Green Bay, and this caught a lot of national attention. It was also was in the Wall Street Journal. And we have what's a dead zone. What's a dead zone? A dead zone means that the oxygen concentration dissolved in the water is too low for the organisms like fish and other organisms to live. That's why it's called dead. Now, there are things that will live under anaerobic and anoxic conditions, like bacteria and certain kinds of benthic fauna, but by and large, not very many things can live in these hypoxic dead zone waters. So why does it occur? Well, there are several things that have to come together to produce this. One is you have to produce a lot of algae. So the Green Bay watershed is a third of the total surface area or watershed for the entire Lake Michigan basin, and about a third of the total nutrient loading comes out of the Fox River. And it's not flushed very fast. The average flushing time for Green Bay is is about a year, okay? And of course we've been polluting the system with excessive nutrient for a long time, so this is not a new problem. It's one that we have just identified and mapped, sort of extensively in the last few years, but it is certainly in the last 10 years, but it certainly is not a new problem. So several things have to occur. One is the over-fertilization of the system. We know, and Joel mentioned this morning, that we have excess nutrients running off the landscape, and it's a rural problem, it's an urban problem, it's everybody's problem. The great thing about the Clean Water Act is that it regulated what's known as point sources, those discrete pipes and fissures that discharge directly into surface waters, things like municipal sewage treatment plants. It did not do a very good job with respect to addressing what's known as non-point. That's the stuff that runs off farm fields and city streets. I have a neighbor, I live in Milwaukee, I have a neighbor down the street. When he fertilizes his grass, he runs a fertilizer spreader right across the sidewalk. I say, Joe, I don't care how much fertilizer you put on the sidewalk, you will never grow grass. But of course, every time it rains, that washes right into the storm drain and goes right into the river and eventually into the lake. So in many respects, the non-point source problem is a sociological one. We have to change the habits. We can no longer point our fingers at, a dozen point source discharges. We have 50 to 100,000 different. Everybody who owns a piece of land is part of this problem. That excess nutrients comes into the system and produces these algal blooms. These are all photographs of Green Bay waters. The unique thing about Green Bay is because of its morphology, it's not very well flushed. And so this material really doesn't have anywhere else to go. So Green Bay is a terrific trap for algae, for suspended sediments, everything. And the sediment accumulates very quickly in the bay. So most of it stays there. Well, it's great for Lake Michigan because otherwise it would flow into the lake, right? So Green Bay really attenuates the flux of material going out. The other thing that has to happen is you have to sequester the water so it no longer contacts the atmosphere. So lakes, in the summer, when surface water warms up, warm water is less dense than cold water. And so it floats on top of the cooler bottom water. So what you get is a sort of stratified system. As the lake stratifies, and it's starting now, and will probably be really well stratified by the end of the month. As soon as that stratification occurs, that bottom water is no longer in contact with the atmosphere. So that means that the oxygen present in that bottom water has to last until the lake cools down again in the fall and the whole system remixes. So that's what's known as summer thermal stratification. And that's the system, that's what we have here in Green Bay. So that's warm surface water acts like a cap on the system. And the other thing about Green Bay, which is interesting, is not only does thermal stratification occurs, but because it has this intimate connection with Lake Michigan up here, at the end of the Dora Peninsula, cool bottom water from Lake Michigan flows in. When you get a southwest wind in Green Bay, it pushes that warm surface water out. That has to be replaced by cooler bottom water from Lake Michigan. That water is no longer in contact with the atmosphere, and as it flows south along these organic rich sediments, the oxygen concentration slowly gets decreased because of the consumption of the organic matter that's lying on the bottom and in the water column. So by the time it gets down to the southern end of the bay, it's already pretty low in oxygen, and then it can go completely anoxic at times. In fact, as in 2005, there was a fish kill down around Dykesville, where this sort of hypoxic blob of water actually ran right up onto the shore, and tens of thousands of round gobies were beaching themselves because they couldn't get out of that hypoxic water. Now, the gobies are unique in that they don't have a swim bladder, so they don't migrate vertically in the water column. They're benthic, they're bottom-dwelling fish. So if they'd have turned west, they probably would have been okay, because that blob of water came onto the eastern shore. There's some evidence that this problem is getting worse. Here is the number of days that we have seen hypoxia, which is generally described as 2 milligrams per liter. So that's about 20% of what's normal for the system. And there's some evidence that it's getting, and all of these bars are below the water quality standards. So you can see that anywhere from a month to maybe as much as 2 months occasionally. At this particular station, at the lower end of the bay, we're seeing these hypoxic waters. So what's it going to take to restore water quality in Green Bay? In order to do that, in order to figure out what the future is going to bring, you need two things. You need to understand how the system functions, and you need to be able to model that. In other words, you have to have a model which is fairly rigorous and complete in its understanding to say, okay, this is how the system is going to behave, this is how the conditions change, and you need the data in order to make sure that model is verified, it's calibrated right. Because if you don't have the data, then your model isn't worth anything. They say all models are wrong, some models are useful, and that's true, and that's sort of where we're at. And in Green Bay, it's not very simple to do these models because they're very complex. You have hydrodynamic models, you have biogeochemical models, you have climate models, you have watershed. You got to look at the entire system, and all these models have to link together to feed one another. So here's just an example of the Bay model, and this is the kind of complexity that goes into this. This is the surface. So there's computations made for every one of these little squares and 20 little squares below each one of those squares. So some of these models take hours, in some cases days to run. This is a simulation now of, this is water coming out of the lower Fox River, so this is Green Bay right here. This is predicting chlorophyll concentrations, that's algae essentially. And you can see, this runs from late May to mid-August. You can see it recycled now, so this is early. You can see the water coming out of here is actually low in algae, but it's high in nutrients. And then these models can actually predict then an expanding bloom. This is the chlorophyll, this is the algae bloom, and here's dissolved oxygen. You can see this hypoxic zone showing up in the lower end of the bay. So the question is, in order to improve the system, it's estimated that we're going to have to reduce phosphorus loading by 40 to 50%. Now that's going to be a huge challenge. As a matter of fact, Joel mentioned earlier, in the western basin of Lake Erie, it's about the same percentage reduction. It's not going to be easy. But the good news is the models appear to tell us, so this is the baseline conditions. This blue line is where we are today in the model. This was what the model would predict if we had a 50% load reduction in the phosphorus input to this system. You can see it's a significant increase in the dissolved oxygen concentration and a significant reduction in the chlorophyll A. That's good news. That means that the system actually does probably respond relatively quickly to reductions in input. Now, we're not going to be able to flip a switch and get a 50% load reduction anytime soon, but the models are telling us if we do that, we're headed in the right direction. And there's reasons for optimism here in the Green Bay in particular, because I think the agricultural community, the community at large, this group here, I think generally recognizes the importance of water quality and the importance of individual actions. And I think there's some very progressive agricultural producers in the watershed that are looking at new management practices in order to reduce and keep the fertilizer and nutrients on the ground, which is where they want it. They don't want it to go off into the water. One important thing, of course, though, is to manage our expectations, because this is not a simple system. So you say, well, we're going to spend some money, or we'll take some actions, and we're going to reduce the phosphorus load and the water quality go up. Yes, that will happen. But there are going to be years in which it looks like the western end of Lake Erie. I mean, Lake Erie doesn't look like that every year. And the idea is, well, so the system is not steady state, and so you're going to go up and down. Hopefully, over the long term, the trend is improving, right? This also points to the importance of collecting the data. Because you can imagine if I collected a data point here, a data point here, a data point here, I'd say there's no change in this system. That's one of the reasons why we have these monitoring buoys in the opening video that we're putting out there to collect data continuously. Because in a system like the Great Lakes, it will be very difficult to pull out long-term trends because the system is so variable unless you constantly monitor. And when we do this, we learn new things. It's just like when we had satellite imagery for the first time. We learned things about processes on the Earth that we didn't know because we could see the Earth on a new spatial resolution. The same is true of looking at the lakes in a higher resolution in both time and space. Well, what about other, stepping away from Green Bay and just looking at the Great Lakes in general? Joel also mentioned this, a couple of sort of non-conventional pollution threats, one of which you may have read about, also in the Journal Sentinel, and Dan also did an article on this, he's our expert, about the oil pipelines across the Straits of Mackinac, known as Line 5. There are two pipelines here, they were over there, they must be about 65 years old now. The company operated wanted to increase the flow through the pipe. So the way you increase the flow through a pipe of a constant diameter is you increase the pressure. Well, people got, they were a little concerned given how old these pipelines were. Some colleagues of mine at NOAA Lab in Ann Arbor, the Great Lakes Environmental Research Lab, did a model simulation of what an oil spill trajectory would look like. And these three colors represent oil at different depths in the lake. The Straits of Mackinac are probably the most dynamic region in the entire Great Lakes because the winds push water back and forth. So it's not all going downstream to Lake Huron. Water cycles back and forth. And you can see that it gets dispersed here pretty quickly. This would be impossible to clean up. You know, we've had oil spills in the Gulf of Mexico, mammoth oil spills. There are some differences, of course, here. We could not use the same dispersants that they used in the Gulf of Mexico because why? We drink this water. So that's one thing. It's also a much colder area, so decomposition of oil would be much slower. My feeling is we probably would not recover completely from this kind of spill. Well, we've been lucky here in the Great Lakes. We have not had a major spill from a pipeline breaker or a tanker or anything else. But, so there's a lot of pressure actually to close the pipeline. I think there's a proposal now for them to drill a tunnel under the straits and actually run the pipes through a tunnel. That would take a long time to actually accomplish. Until just recently, there were no valves on this pipeline. So if there was a break, they had no way of turning it off on either side of the strait. Now they've corrected that. But pipelines do break. They break with a fair amount of regularity. In fact, as the company that owns this pipeline had one break on the Kalamazoo River in 2010, spilled about 1 million gallons of tar sand oil, which is coming out of Canada. It's cost at least $1 billion to clean up. I think that break occurred on a Friday. Sunday, I got a call from a friend of mine at the water utility in Milwaukee saying, Val, do I need to worry about this? Because the Kalamazoo River flows into Lake Michigan, and that's where we all draw our drinking water. And I said, well, no, I don't think so. My understanding, EPA said they have confined this spill to the Kalamazoo River, and in fact, none of it did get into Lake Michigan, fortunately. This also, a question came up, I think you asked a question about pharmaceuticals earlier. The same property that makes drugs, medicines effective in our body means that they also are translated through conventional sewage treatment largely unchanged. So conventional sewage treatment does not remove these pharmaceuticals, and you can see the entire medicine chest of pharmaceuticals in Lake Michigan. Now, in part, it's a testament to our analytical capability to do this, because these are vanishingly small concentrations in some cases. But there are some that show up pretty much continuously. One of our students, Ben Blair, Rebecca Clappers, did some work with metformin, which is one of the most highly prescribed drugs in the United States. And I'll just use this as an example. And Ben was he's defending his thesis, and finally I raised my hand. I said, Ben, because he was showing concentrations in the lake, I said, Ben, what was the lowest concentration that you measured? And he said, well, the lowest thing, I was thinking, well, they're 5 miles offshore in Lake Michigan, big reservoir, they won't be able to detect it. And that wasn't the case. They could detect it everywhere they went. They estimate that there's 12,000 pounds of metformin discharged from the South Shore sewage treatment plant on an annual basis. Now think about 12,000 pounds of metformin pill. It's a lot, in other words. It tells you two things. That the fact that they can measure it everywhere. One, it's not going away. So it's coming into the system and it's not being decomposed or removed naturally in the environment. The fact is, we can do sort of a back of the envelope calculation and come up with the concentration that we're measuring in Lake Michigan with this sort of rate of input into the system over the last 20 years or so. Joel mentioned plastics, so I won't go into that too much. And nanomaterials, these are things we're concerned about. The number 2050 I put up here because there's an estimate by 2050, the biomass of plastics in the oceans will exceed the biomass of fish. I don't know if any of you saw the 60 Minutes program about plastics in the oceans. It was a month or so ago. Honestly, it was the most depressing programs I think I've ever seen. We do have the technology to try to understand the impacts of these. So that's the question. They're in the system. Are they having an impact? Because they're very low concentrations. Obviously, they're good for us or do good things for us. The question is, in the environment, are they having an impact? And in some cases, they're not having an impact. It's very difficult to figure that out. There are synergistic effects. We can find drugs which by themselves don't appear to have any measurable effect, but when you pair them with another one, and these are at concentrations that we measure in the environment, do have an impact. I'll give you one example of a drug that Rebecca and her students, Prozac, which is, you're familiar with Prozac. They dosed fish that have fathead minnows. They have a very elaborate breeding behavior. The female lays her eggs underneath a rock, the male fertilizes it, and then he'll guard that nest until those eggs hatch. Well, very low concentrations of Prozac. The female just broadcasts her eggs in the bottom of the tank. The male, he doesn't care. In fact, if you read the warnings for human use, same effect actually. But the point is these are at orders of magnitude below, concentration below where we could see any other sort of toxic effects. These are behavioral effects that essentially eliminate reproduction in the system. An example I always give, many years ago when they were looking at oil contamination impact on lobsters. Lobsters, before they mate, they molt. Well, they're notoriously cannibalistic, so it's very important that the male and female understand we're going to have, we're going to mate, we're not going to eat one another. As it turns out, concentrations of oil contamination, 3 orders of magnitude below anything else ever interfered with that communication between the male and the female. The result was, reproduction doesn't work. I got to remove the audio from this, but in any case, Joel also mentioned invasive species. There have been some 180 different invasive species. And you're probably familiar with the sea lamprey, the alewife, the round goby, and these drysynid mussels. Now in this video, this was taken quite a while ago actually, two things to notice. One, all of these rocks here are now covered, these were with zebra mussels. That didn't used to be the case. And the other thing is look how clear the water is. It looks like the Bahamas. And the reason for that is because they are very effective filter feeders. That was in the early 1990s. In the early 2000s, another drysynid, a sister to the zebra mussel, quagga mussel it's called, invaded Lake Michigan. And it's the same, for all intents and purposes, it looks the same, but it had two different characteristics that were different. One, it could live on a soft bottom, whereas zebra mussels had to have some rock or hard substrate to attach to. Quagga mussels could live on soft bottoms, and they could live in much colder and deeper water. And as a result, very quickly, they took over Lake Michigan. You are hard-pressed today to find a zebra mussel in Lake Michigan. Fish populations took a nosedive. Here's a trawl that was taken several years ago off the stern of our boat. This is a bag full of quagga mussels. There was one fish, a round goby, which is also not native to the system. Interesting, just a side note, you know, the electrical barrier that Joel mentioned on the Chicago Drainage Canal, designed to keep out Asian carp, was actually originally designed to keep round gobies in. So the door was originally slamming the other direction. Here's a video taken by Harvey and his crew. This is a benthic trawl in Lake Michigan, and this goes on for a long time. You can almost walk across a carpet of mussels now in the Lake Michigan. This has totally changed this, re-engineered this system. Lake Superior, these are very efficient filter feeders, so they suck all the material out of the water column. Lake Superior, which is one of the most pristine lakes in the world, is now the third clearest lake in the Great Lakes. The offshore waters of Huron and Michigan both have higher water clarity than Lake Superior, and it's because of these mussels. There's been an enormous decline in the phytoplankton and in the primary production. And there are other ripple effects. If anybody tells you they can, you know, any ecologist says you can predict the impact of an invasive species, forget it. There's no way. One of the things that resurged then in the near shore is this algae, Cladophora, referred to as horsehair algae, needs three things to live. And this algae, by the way, was the poster child for phosphorus removal back in the 70s when they took phosphorus out of the detergents, because this was very phosphorus dependent. You need something to attach to, it needs nutrients, and it needs light. And mussels have provided all those things. Because they've filtered the water clarity has increased, so now the near shore area is much more illuminated than it used to be. So now the habitat for this has expanded. They bring the nutrients to the bottom so that it gets this luxuriant growth. So these vast meadows of Cladophora out there. There are mussels here, they're just underneath this algae. They're happy as clams, as they say. When this stuff senesces and dies, it washes up on the beach, stinks to high heavens. Everybody blames the sewage treatment plant. It's not the sewage treatment plant. Have the same problems up here in Door County. It goes anaerobic. The organism, which is produces a botulism toxin, avian botulism, flourishes in this, and when birds feed in this, they end up taking up this toxin, and we have a resurgence now of avian botulism in the Great Lakes. So you can never predict what the impact is going to be downstream of an invasive species. So the Great Lakes have gone in both directions. I mean, we have unprecedented nearshore algal blooms, and this is Western Basin of Lake Erie, and this is offshore water clarity. It looks like the Bahamas. Well, what about climate change? How am I doing? Okay. I've been giving talks about this issue for a long time. For 20 years, I've said the same thing every year. The 10 warmest years have all been in the last 15. As a matter of fact, the 5 warmest years on our historical record have been the last 5. For our region, it's predicted to be both wetter and warmer. And these are predictions for Madison. Nearly 2 weeks, summertime highs over 100 degrees. Now, I've lived in Milwaukee a long time. I can't remember maybe one day where it ever hit 100. I'm not sure. It's also predicted to be wetter, a 10 to 20% increase in precipitation, but that precipitation is projected to come in more frequent, intense events. Here is surface water temperatures where purple is warm and green and blue is cool. This is 1992, which is and 2012, which when I made this slide was one of the hottest years on record. Now it's not even in the top 5 anymore. Water temperatures in Lake Superior have increased about 5 degrees Fahrenheit. As a matter of fact, water temperatures are rising faster in Lake Superior than air temperatures. And the reason for that is because when the lakes are ice covered, they reflect the sunlight and don't absorb heat. When the ice moves off the lake, they can now absorb heat from the sun. As the ice-free period gets shorter and shorter because it's warmer and warmer, The period of time which it can absorb the heat from some gets longer, and the lakes heat up faster. The biggest probably impact the climate is having is on lake levels. Now, lake levels are controlled by two things: the amount of precipitation that hits the ground and the amount of evaporation. Everything else has very little effect. There's no plug we can pull out or plug we can put in, despite people who wish that would be the case. Because it has been warmer, one of our atmospheric scientist, Paul Rober, and his students looked at the hydrologic balance in the lakes, and they looked at if you separate just out the evaporation term, because it's been warmer, evaporation has increased. And you see in the fall when the lake is steaming, that's when it's losing a lot of water. Evaporation has increased by about 25% since 1980. That would have dropped lakes levels by several feet. But because it's been wetter, most of that has been offset. And right now, as you know, up until 2013, which was the all-time low, we had the longest period of low, below average lake levels. Now it's been cool and wet recently, and lake levels are back up again. So here's that record. Here's where we are today. You can see the all-time high was 86, 87. The all-time low was 2013. We're still well within the boundary of what we expect. In terms of the future, the models are all over the map, you might say, but in general, most of the models seem to think that the warmer tends to trump the wetter. So lake levels are generally projected in the long run maybe to get lower. But one of the things we do know, and the models are predicting, is that variability about the mean is going to be enhanced. So in fact, if you're going to predict the future, you say we're going to get lower lows and higher highs. So the worst of both worlds, if you would. And of course, increase in intense rain events like the 100-year storm. Seems like 100-year storms are coming every 3 or 4 years, and in fact they are. And of course the infrastructure that we have is just not designed to handle those. So the major challenge, as Tony Summit has said, is to reconcile the inherent conflict between human activity and environmental sustainability, and nowhere I think is that challenge greater than when it comes to water. Joel mentioned this too, the Great Lakes Restoration Initiative. So if you want to take action, contact your politicians, make sure they support the Great Lakes Restoration Initiative, and most of them do. The administration has tried to cut that. This year they backed off on that. And I also think we should set a target for restoring the Great Lakes. Let's get out of the restoration business. Let's say we're going to restore the Great Lakes by some date, and then start down that road. I've suggested 2040. We can debate what that date. It could be 2050. We could also debate what restoration means, right? Because you cannot turn back the clock. About water bills and saying how water rates are going up. And I read this in the paper, and people were writing letters, my rate's going up 30%, my rate's going up 40%, they got upset. Finally, I got upset. I said, time out. You're not paying anything for the water. What you pay for is the withdrawal, the distribution, the treatment, the putting back. The water comes to you absolutely free. You don't pay a thin dime for the water. So obviously the value of the water at the end of the pipe that you and I use it, or a brewery uses it, or whoever, now it might be difficult to figure out, but we could probably figure that out, right? The value of the water at the other end of the pipe, the end of the pipe that's in Lake Michigan, that's going to be difficult to figure out what the value is to the system. But I can guarantee you this, it is not zero. It's not zero, and we do not pay it. Like every other activity we do, we ask the environment to subsidize what we do, and we never pay that subsidy. So my proposal is to put a surcharge on water use, a couple of cents per 100 gallons, which is what the average family uses in a day. So it's 10 cents a week. It's $12 a year. It's not. Most people can't tell you what their water bill is because it's not that much. What is expensive is the sewer bill, obviously. Someone also said we don't inherit the environment from our ancestors, we borrow it from our children. And this is a good thing to remember, because someone said also, the future has no constituency. Our great-great-grandchildren come back to me and say, Val, why don't you solve this problem? Why don't you, leave it for us to deal with? No, I think it's our generation's responsibility. And one final point here. The Great Lakes are essentially closed systems. So the water residence time for Lake Michigan is about 100 years. So for all intents and purposes, anything you throw, toss, leak, whatever, let get into the system. And I say, if you dump it in today, there's a good chance you will drink it tomorrow, or if not tomorrow, sometime in a not too distant future. And of course, we are mostly water, right? 70% of our brain is water. So my point is, you live around here, you drink water, you are mostly Lake Michigan. You are more Lake Michigan than you are anything else. So just think about that. And so what's it going to be? Happy trigger finger here. These are both unretouched photographs of the Great Lakes. This one happens to be Lake Erie. That's a wake of a boat and algae spewing up, and this is, of course, the offshore waters of Lake Michigan. We're at the School of Freshwater Sciences. We've been at this location for over 50 years, but the school itself is relatively new, formed in 2009. Now, I'm not a Facebook person, but if any of you are, you want to make my staff happy, you like us on Facebook, and they'll like, Val, thank you. And finally, a little ad. I got a couple minutes left. The opening video was of our research vessel, the Niske, which is 65 years old. Great boat. We have fantastic crew, but it's reached the end of its lifetime. And so one of my current pet projects now is to raise funding for a new research vessel designed by Seacraft Designs here in Sturgeon Bay. So if any of you feel, inordinately generous, am I right? Check do not go last evening. So thank you very much.